All right, here we go. So integration, as I just said, is the reverse process of differentiation. So let's first look at if you have something like this. Okay, when you differentiate this, you would go 3 times 2. Okay, so the power times the coefficient, and then you take 1 away from the power. Okay, so when we are going backwards, we're doing the reverse process. So the last thing we did was take away 1. So the first thing we're going to do now is add 1. So this is my, what do you call it, a function. I'm going to add 1. And I'm going to divide by the new power. And if there was a number, a constant, it would have differentiated to 0. And to take that into consideration, I'd have to put in a plus c. Okay, and c could be 0, like in this case it is in the example we just did. So just to go over the notation, this little line here that you see, this one, it says integral or integrate. Okay, and this little bit here that you see, it tells you what you are integrating with respect to. So it's saying integrate. I'll make it thinner. With respect to x, so that's what it's saying. So if it was dt, then I would be integrating with respect to t. So that's the point of that dx. So really the function that I'm looking at is this bit. So the dx is just there to tell us what we are integrating with respect to. Okay, so I just want to do a couple of questions so everyone is fairly familiar with this and happy. So I'm going to do this one here, square root of x. So integrating square root of x. Okay, so the first thing is you always want to write this in power form. So square root of x is x to the power of a half. Now I'm going to be adding 1 to half. So that's 3 over 2. And now I've got to divide by this new power. So when I'm dividing by 3 over 2, it's multiplying by the reciprocal. So 2 over 3. And then let's not forget the plus here. Okay. Now, if you have something like this, I'll do this question here. Now, what is important is that we understand that this is for each term. So I've got to split this up into individual terms. So that's my first step. So I'm going to go t to the power of 4 over 2t squared. So it's t squared over 2. And then t cubed over t squared, that becomes t, and the 2's cancel out, plus 1 over 2t squared. So the first step is to split them up into individual terms. And when you've done that, again, what we've just done before, we're going to do them individually, each term by term. So add 1 to the power and divide by the new power. So I've already got a 2 and I'm dividing it by 3, so that becomes 6. So here, adding 1 to the power, dividing by the new power. Now this one here, so I've got 1 over 2t squared. So I'm just going to remind you that that is the same as 1 over 2 t to the power of negative 2. Okay, so that's what it is. Okay, so I'm going to add 1 to the power, which makes it t to the power of negative 1. Shh. Okay, one moment, guys.
Mommy.
Shh. Again. All right, so here we go. So we've got 1 over 2t squared is written as half t to the power of negative 2 because I can't have the t in the denominator. So now I'm adding 1 to the power, so that becomes t to the power of negative 1. And then I'm dividing by negative 1. So this becomes All right, apologies, guys. Okay, so again, I'm going to start again. I apologize for this. So t to the power of -2, I've added 1. It's going to be 2 to the power of -1. And I'm dividing by the new power. So there's a plus here. When you divide by -1, it just becomes negative. Okay, so there we have it. And don't forget the plus here. Now you can rewrite this in just with a positive index. So that becomes okay, so there we have it. So this is your work from yesterday. So the first thing is you have to add 1 to the power and divide by the new power. And of course, this is after everything is as written as an individual term. Okay, so that's integrating polynomials. Now, the next thing, again, this is something you have done last year, but I'm just going to remind you again, finding the constant of integration. So finding what C is. So what you have to understand is we can only work out what C is if we have some kind of condition. Like in this question here, we've been given the derivative, and the only way we can work out C is if they give us condition like when x is 1. So this is what this means if you're not familiar with this. So f of 1 means, so when x is 1, y is 2. That's what they're saying. Okay, so first you just find the general antiderivative. So what it means is you're just going to integrate this, okay, which gives you x squared, and 12 divided by 2 is 6, plus 4x plus c. Now this is your general antiderivative. Now substitute the given condition. So when x is 1, y is 2. So 2 is 6 times 1 squared plus 4 plus c. So that's 6 plus 4 is 10. So 10 plus c is equal to 2. So c is equal to 2 take away 10, which is -8. And then you write out the full function. So y is equal to 6x squared plus 4x minus 8. That's your full function at the end. Okay, so again, that was hopefully not new. So even though I went through it a little bit fast, I hope you are fairly familiar with it and are not too confused about that. Okay, so today there's something new that we have not done last year. Okay, so I'm going to... Okay, so today we're looking at integrating exponential functions. So as I said before, integrating is the reverse process of differentiation. So the first thing you should be looking at is, how would I differentiate an exponential function? So if you had e to the power of 5x and you were differentiating, what would you have done? So we know the derivative of the exponential function is itself. Okay. But this is a composite function. There's a function within the function. So the derivative of 5x is 5. So I'm going to multiply by 5. So it gives me 5e5x. So if I was going backwards, okay, so here I am going backwards. First, I know the function is itself. So it's going to be e to the 4x. So write that out as it is. Now, when I differentiate it, I multiplied by the derivative of the power. So here, when I'm integrating, I'm going to be doing the reverse, which is divide. So I'm going to be dividing by that, okay? So now what you have to understand is there's possibly a constant that we differentiated to 0, so we have to take that into consideration and add c. Okay, so just to recap, the derivative is itself, but then you have to divide by the derivative of the power. So if you have something like this, just like with the polynomials, you've got to have them as individual terms, write them out as individual terms. So simplify this. So e to the power of 5x over e to the 3x. So the same basis. When you're dividing, you subtract. Okay, again, same thing. This becomes e to the -x. So that's the first step, simplify. And then you do them individual terms. So e to the power of 2x divided by 2. And this is e to the power of negative x divided by negative 1, so that becomes positive. All right. And don't forget the plus sign. Okay,